So the next topic in chapter 4, this is the last topic, the continuous probability distributions. We are going to look at one distribution actually. There are many, but for your course, I don't think they will be much useful. Therefore, we are going to look at the normal distribution in detail, or the Gaussian distribution. You have maybe you have heard about this one, and actually you have used it. This distribution contains the Z score. The Z score that you see in your advanced level examination ranking, that Z scores are calculated using the normal distribution. So I'll show you how to get the Z scores and properties of this distribution. The normal distribution is the most common and widely used distribution in statistics, because most of the statistical theories are proven and most of the statistical methods were developed assuming the data is normally distributed. Okay, the reason is, if you look at a collection of data, collection of observations, or some values that you measure for a certain variable, if you have large enough number of observations, usually they follow the normal distribution. That is something natural. Okay, if you think about heights of a population, weights, examination scores of a set of students, if you have a large sample, usually these type of variables, they follow the normal distribution. Okay, so I'll explain the properties, then you can understand it. If not, the averages will most often follow the normal distribution, and that is actually a theorem. In almost all the variables, if you think about the averages, they follow or they approximate to the normal distribution. Okay, so that is why normal distribution is very useful, and you have to learn it because almost all the theories and statistical methods are developed assuming the normal distribution. So if your data set is normally distributed, then applying statistical methods becomes very easy. Your life becomes very easy. You don't have to do any transformations or any cleaning to your data. You can straight away use mostly available statistical methods and tools on it. So normal distribution is something very nice to have in your data set. Okay. So we call it normal distribution or the Gaussian distribution because this was developed by Carl Friedrich Gauss about 1809, I guess, right? This is the same Gauss that you see in electromagnetism in physics. Okay, so that same person. So he came up with the idea of this normal distribution and developed all the theory behind it. Okay, and if you look at the definition, this is how we the function will look like. Now this is a continuous type of distribution. Okay, not like the distributions we talked in previous lesson. Those are discrete. Discrete means you can have only whole numbers. You don't have any fractions or decimals, or in between numbers you don't have. But when it comes to continuous kind of type of random variables, if you take if you look at a given interval, all the values within this interval will be there for continuous case. So you have all the decimal values, fractions, and everything. Like height is 26.78 degrees Celsius. Like things like that. So when you have continuous type of distributions, depending on the, usually it is the shape that define the equation of this function. So this is actually a function. Don't worry about these equations. You don't have to memorize them. Okay. For any continuous type of random variable, if it has a distribution like this, so this is the function fx. Okay, you can write an equation for this function. Okay, so there are several common features that you can find in random variables. Some of them are like this. Some of them are like this. Some are like this, right? So the normal distribution is nice bell shape. So we'll come to that later. So depending on these shapes of the distribution, you have different type of distributions. So just to name them, you don't need to memorize them, just for your reference. Okay, you have the uniform distribution like in the discrete case. where you have for a given interval, say A and B, all these values contains the same number. Uniform is, it's the same probability. Okay. So actually you take the width of this interval and divide it at the width of the interval, and 1 divided by that width of the interval, you get that P. So all the points will have the same probability. Okay. So that is the uniform. Then you have the normal distribution. Then you have something called the exponential distribution, where you have this type of patterns. And then we have T distribution, F distribution, chi-square. You will see this distribution in future chapters. I'll explain them. Okay. And in addition to that, there's beta distribution and gamma distribution. You will not use them a lot. Okay. So just to give you some names. Okay. So in addition to that, there are many other. Okay. So all these distributions, they have certain equation like this, and according to the shape and everything, that this function will explain it. Okay. So if you look at this function, it is not easy to, figure it out like what it says, but you can see a few things there. You can see how it is written. Here's the random variable. Now you are familiar with this formation. The random variable is x, and these are the parameters. This is like even in the binomial Poisson, you have seen this, the way of writing it. You have the variable, semicolon, and the parameters. For binomial, we had two parameters, n and p. Poisson, we had only one parameter, lambda. Okay, so likewise, the normal distribution, it has two parameters, mu and sigma. Actually, this is the mean and the standard deviation of the random variable, x. Okay. So you see these values in your equations. You see sigma here. Then you have square root of 2 pi as a constant, and then you have x minus mu. So you see the mean here and sigma again. Okay. And the support of x is from negative infinity up to plus infinity. That means the whole real number line. Okay. So all the values from negative infinity to positive infinity, you can explain using the normal distribution. Okay. So these properties of the normal distribution, let's explain using the parameters also. The first thing is, this is a symmetric distribution. It is symmetric about mean. What is the mean? Mu. And it is bell-shaped. So it will look like this. So this is the number line. Nice symmetric bell shape. It is symmetric about the mean mu. So that means exactly 50% of data to the left, 50% of data to the right. Now what is the total probability? The total probability one will be the area under the curve. Okay, so the total probability is 1. That will be the area under the curve. So in discrete case, you calculated probabilities, okay, using a certain equation or the table. Similar to that, for the normal distributions, when you have to find probabilities, usually they will look like a function like this. So if you want to find a certain probability, that probability will be the area under the curve. So for 2 points A and B, if you want to find the probability that x is in between A and B, that will be the area under the curve. Okay, in order to find the area under the curve, you have to integrate this function from A to B, but we are not going to look at those calculations because we have tables and we can read the table and get there. So there's no need of doing integrations for these functions. Okay, and even if you think about integrating this normal distribution, this function, it's not going to be easy. It's very complicated. Okay, right. So the area under the curve will be the total probability. Okay. And remember something important for continuous random variables, continuous probability distributions, you don't have a point probability. Okay, so what does that mean? In binomial distributions and Poisson, you can find probability x equals a certain number, right? You can find x equals 3, x equals 5, you can find it. But for any continuous type, not only normal, any continuous type distributions, you cannot find that probability x equals 1. Why? The point probability, say this is C, probability at C, that is 0. The point probability is 0 because if you integrate this point, you get 0. Okay. So therefore, for continuous case, point probability is that is 0. Okay. So you do not calculate Px equals some number, but for discrete, you do it. Okay. For discrete, point probabilities are available, but for continuous, point probabilities are it is 0. Okay. So always you need an interval like from A to B or C to D, something like that. Okay. So keep that in mind also. Back to the normal distribution, you have the bell shape and the two parameters will define actually the shape and location of your bell. Okay. So if you have any questions, please stop me and ask. Okay. So while we are doing the class, the mean is called the location parameter because it will define where the bell will place, location parameter, and sigma or the standard deviation or the variance sigma square will be the shape parameter. Okay, that is the shape parameter. And you have total probability will be the total area under the curve. Okay, so what is the meaning of this location and the shape? Okay, so I'll explain it using a few examples. Now, suppose I say X is a random variable. It follows normal distribution with mean 5 and standard deviation 2. So this is how we write the, this is the notation of writing the normal distribution. X follows, this is the tilde. X follows normal, capital N for normal. You give the values of the two parameters, mean equals 5, sigma equals 2. Okay, so what does that mean? So here's your number line. You have 5 here. The bell should be located around 5, right? It is symmetric about the mean 5. It's always symmetric about the mean, right? And you have the standard deviation 2, that will be the shape. Say, I'll explain it using another one. Now, suppose your y variable is another normal distribution, same mean, but now the variance is, let's say, 4. What does that mean? The standard deviation. Now it is larger than the previous ones. Still, it is symmetric about the mean 5. So the location is same, but now it has a larger variance. Now what will happen? Your bell will be very fat. So it will look like this. Still symmetric about 5, but your bell will be like this. Okay, so it will go there. Anyway, the total area under the curve should be 1. Okay, so it is not like this curve is half of the blue one. Red is not the half of blue one. Okay, so it has it goes somewhere there. Okay, so anyway, the total probability will be 1. So you can see the difference, right? Same location but different shapes. So that is why sigma is called the shape parameter. Now, say for example, I have another variable, say w. So my W is another normal distribution. Now with again the same mean, say sigma is sigma is 1. Now what will happen? Again, still at 5. Now your bell will be very, very, very thin. So how it will look like this. Okay, very thin. Now my bell is not very nice, but it will be very thin bell, still symmetric about the mean 5. Okay, so you can see the difference of the shape. Still same mean, different standard deviations, you get different shapes. Now what will happen, say my y, xy, what is the variable I should use? Say u follows normal with, let's say sigma is same. Now the mean is 10. Now what will happen? Now your bell will shift to 10. Sigma is 2, it's the same, but so it should be same shape like the previous blue one, right? But it is now symmetric about 10. See, it shifted. So that's the location. Okay, when your mean is changing, the bell will shift to the left or to the right. Okay, so that is how the two parameters will shape the normal distribution. Okay, is that clear to all of you? Okay, since it's okay now. Um, okay, so we have the bell shape, it's symmetric. What else? Okay, so the other property is the tail probabilities are very low. Tails are thin. What does that mean? Okay, so I have a question. When mu is same, does that mean the area under the curve is same? You mean the total area? The total area under the curve should be always 1. Okay. But when you calculate probabilities, you will have different areas. Okay. Now, depending on although the mean is same, if the standard deviations are different, the bell, it will be fat or thin. Okay, then when you calculate the areas, depending on that shape, okay, it will cover a certain area. Okay, so, but the total area under the curve 1 is, it remains. Okay, so always the total area under the curve is 1. Okay. So the tails are thin, that means like this, right? So the normal distribution towards the end, the tail probabilities, these are very, very low probabilities, approximately 0. That means the area that covers these tails are very, very low. So it is approximately 0. Okay, so 0 probability. Towards the negative infinity and the plus infinity, the area that covers from the tail, they'll become almost 0. Okay, that means the tails are very thin. Because we have another distribution, we'll learn it later. They have the same properties as the the normal distribution, but tails are thick. Okay, so that is why we have this special property. The normal distributions, the tails are very thin. Okay, right. So those are some properties of the normal distribution. Okay, now when you have the symmetric about the mean, what is the other measurement that will fall equal to mean? What is the other measurement? You know several measures of location that you have learned in very early chapters, mean, median, mode, and so on. So if you have the symmetric about the mean, 50 to the left and 50 to the right, what is the other measurement that will be same value as mean? Yes, that will be the second quartile or the median. Okay. So the median or Q2, okay, they will have the same probability. Okay. Now let's look at some examples where we can use this normal distribution. Okay. So here's an example. Exam scores of students in a class is normally distributed with mean 80 and standard deviation 8. Now what does that mean? Now suppose you have set of students, let's say 100 students. You can calculate the average. Okay, you can calculate the average and you found it is 80. And you calculate the standard deviation, that also you can do, and you found it 8. And it says this, it's normally distributed. What does that mean? If you draw a histogram for this data, it will be nice symmetric distribution like this, right? So somewhere around 80, you have this value, and see, you have the nice bell shape, right? So that is the normal distribution. Now, when you have the normal distribution, what if you want to find probabilities like, what is the probability if you select a student randomly? Okay, let's say if a student is selected randomly, what is the probability that that he or she has score, let's say, greater than 90. But if you want to find something like this, you select a certain student, what is the probability that his exam score is greater than 90? Or let's say probability that exam score is less than 60. Okay, if you have the pass fail mark 60, okay, so you should be able to find this type of probability. And you can, if you want, you can find what is the um, third quartile for exam scores. It is the third quartile for exam scores. If you want to find that, that means the 75th percentile, right? Well, you should be able to do that. Okay, so your X follows normal distribution with mean 80 and standard deviation 8. Now, if you go back to the normal distribution function, this one, right? The equation where I have squared. Now, if you are going to find a probability like this, okay, the exam score get greater than 90. So if you use the usual method, that means you have to find the normal distribution. Okay, this equation. This is the equation. You have to integrate this form over the support of x. Now in our case, that will be, you have to integrate from 90 to the maximum exam score is 100. Sigma is 8, square root of 2 pi, e to the negative 1/2. X minus 80 over 8 square d. Now you have to do this. Okay. Now it is even we don't do that, right? But there must be a way to find it, right? Because statistics is not used by only mathematicians or statisticians. Almost all the fields, social sciences, economics, biosciences, medical sciences, they all use these statistical tools, and then they have to find the normal distribution probabilities. Well, we cannot expect all of them to do these type of integrations. So therefore, there must be a way to solve these type of problems very easily. Okay. Therefore, we have something called the standard normal distribution. Okay, so we have the standard normal distribution. That means any normal distribution with any mean, any standard deviation can be transformed into a standard normal distribution. Okay, a standard normal distribution is where you have mean 0 and the standard deviation 1. That means variance is also 1. Variance is the square of this, so 1 square is 1. Okay, so a normal distribution with 0 mean and standard deviation 1 is called the standard normal distribution. And any normal distribution with any mean mu or any sigma value can be transformed into a standard normal distribution. And that transformation is called the standardization, where you find the Z score. So this is the standardization. Okay. That means you take the random variable, subtract the mean, and divide by the standard deviation, you get the corresponding Z value, and that Z will follow a normal distribution with mean 0 and standard deviation 1. Okay. Now this is again a normal distribution. So the properties that you have with the normal distribution, that will be same for the standard normal distribution also. But special case where you have 0 mean and the standard deviation 1. Okay. Now the thing is, we have tables available for the standard normal distribution. Therefore, you can easily read these tables and get the probabilities. And for any random variable following any type of normal distribution, that means whatever the mean, whatever the standard deviation, you can always convert it into the standard normal distribution using this standardization Z score, and then read the table and you can get the probability very easily. So no need of doing any integrations or hard calculations. Okay. Now what is this standard normal distribution? So as I mentioned, it is a normal distribution with a special characteristics, mean equals 0, sigma 1. So still it's the bell shape. And it is symmetric about what? We know the normal distribution is symmetric about the mean. And mean is 0. So it is symmetric about 0. So same bell shape, and you have the symmetry about 0. So you have positive Z values to the right and negative Z values to the left. Okay. So usually, although X or the usual normal random variables can contain values from negative infinity up to plus infinity, when you standardize, usually the Z values are more than greater than plus 5 or less than negative 5. Those tail areas are actually negligible. Okay, so those are almost 0 after Z score negative 5 or positive 5. Okay, so therefore usually the tables, they stop the values after 4.5. Okay, I will show you the table and then you can see it. Okay. So here's the standard normal table. You do the standardization and convert your normal distribution to the standard normal table and read the table and get whatever the probability you want. Okay. Right. So here's the normal distribution table, standard normal distribution table. Okay. Now we have to, so this table contains negative 3.9. Okay. So you can see the smallest value is 0.00003. So this is the smallest probability value. This is actually, almost 0, right? 0.00003. So this is the left part, or this negative part of your Z score. Okay, it's from negative 3.9 up to 0, okay, plus or minus 0. And see, you have the 50%, 0.5 probability. Okay, and always remember, these are, see, area to the left. Always your table gives the area to the left. So if you read a certain Z score, this area is the probability, the left tail, always the left tail. Okay, you don't have the right tail probability when you read the table. It is always the area to the left, okay, of the Z score. Okay. Now let's look at the other page also. That is the right side. Okay, this plus Z values. You have the other table. Even with one table, you can do the calculations, but it is easy when you have both pages. So this page, see, 0 up to 4 it is given. So it has, this is the maximum probability, 0.99999. So this is almost 1. Okay, so that's the total probability. It start with 0.5, where it's end in the previous page. Okay. Now we'll see how you can read the table, right? I'm going to make this a little smaller, right? Okay. So here's the table. Now I'll give you a few minutes to look at it. Okay, what are the things that you can see here? So you have columns, rows, bunch of numbers. Okay. So those who have done mathematics for A levels, they have used this table. So when you have your A level results, when you have Z score 1.9, what is that? So you will see that, okay, in your when you do these calculations, you will get the idea about your Z score. Okay, so what do you see? You see the first column, you see Z. Okay, these are the Z values, the negative Z values up to the first decimal place, negative 3.9, okay, up to 0, the first decimal place. If you look at the very first row, you have 0.001, 0.01, and so on. So these are the second decimal places. Okay, these are the second decimal places that you see in the first, very first row. Okay, now we know that this table gives you area to the left of the Z score. Okay, so I'll show you what does that mean. Now here's my the bell. Okay, so here's my bell. symmetric about mean 0. And I have Z score, let's say this point is negative 2.54. Negative 2.54. Okay, so can you find negative 2.54 in this table? So how do you do that? Now this is the Z score. Okay, this is the Z. Now your number line contains Z values, negative 3.9 up to positive some value. Okay, this number line. So somewhere here you have negative 2.54. What does that mean? Up to the first decimal point, 2.5, you find it from the first column. See, here's your negative 2.5. Can you see it? Negative 2.5 is there. Second decimal place is 4. 0.04, here's the column. Here's the second decimal place. Can you see that? Second decimal place is 4. So you go along negative 2.5, that row, until you come under the second decimal place. So you find a certain probability. What is that probability? 0.00554. What is that probability? Area to the left of Z score negative 2.54. So this area is the probability 0.00554. Okay, let's try another one. I want to find, here's my bell. Now my Z score is negative 1.97. I want to find area to the left of negative 1.97 Z score. How do you do that? Where's your 1.9? 1.9 is here. See, negative 1.9. What is the second decimal place? 7. Where's 7? So here's 7. Right. So you go along negative 1.9, this row, all the way until you come under 7. See, here's the probability. What is that probability? This area under the curve is same as the probability. That probability is 0.02442. Is that clear? How do you write this? Probability that Z is less than negative 1.97 equals 0.02442. So that is how you write the probability. Okay. Is this clear to all of you? Now with that, can you find the probability Z is greater than negative 1.97? What is that area? Greater than 1.97. That is the right side of the tail. How do you find that probability? What is the rule that you can use? Anybody who can find this probability? Remember that the total area under the curve is 1. That is the total probability. If you have left tail 0.02442, what will be the right tail? That will be, yes, 1 minus. Thanks for the answer. You have 1 minus 0.02442. So that is how you find any probability to the right of the Z score. When you read the table, you get the probability, the left tail. If you need the probability of the right tail, you have to do 1 minus. Okay, always you do 1 minus and you get the probability you want to the right of the Z score. Okay, so that's very, very simple and very easy. Now, what do you think? What is the probability Z equals negative 1.97? What is that probability? Z equals negative 1.97. This is continuous distribution. What is this point probability? Always it is 0. So if you write Z less than or equal or greater than or equal or simply greater than less than, it doesn't matter because equal is 0. Okay, so you don't have to worry about whether you have the equal sign or not when you calculate probabilities with the normal distribution because the point probability is 0. Now remember, with the binomial Poisson, it is not the case. Okay, the equal sign matters for discrete, but with the continuous, whether you put the equal sign or not, it's not going to change anything because this point probability is 0. Okay, so is this clear to all of you? How to find the probabilities? Let's go to the right side. Okay, let's go to the right side. Okay, let's try an example. So I want the probability. So here's my bill, 0. I want the probability. Now my Z scores are in the positive side. Okay, so let's suppose this is my 1.28 positive. I want the left tail or left to the 1.28. What is this probability? Can you find it? If you can find the values, please give me the answer. So how do you write this? Probability Z is less than 1.28. Yes, what is the value? Okay, so 1.2 is here. See, 1.2. And then you have second decimal place 8. All the way up to 8. So here's the number. I got few answers. Yes, 0.899973. Thanks for the answers. So this will be 0.89973. What is it actually? You can say 89.97%. Okay, if you want to write it in percentage. So you see now the probabilities are greater than 50%. Why? Because your positive Z scores, see, your positive Z scores are to the right of 0. So you know, by symmetry, this side contains the first 50%, this side contains the upper 50%. So any probability to negative Z scores, your probabilities will be less than 0.5. But when you exceed 0 and when you find probabilities to the positive Z scores, they will be always greater than 50%. So you will end up with some big values, right? So shall we try another one? Okay. Let's try another one. Tell me the probability to the right of positive 0.95. 0.95. Okay, first find 0.95. Here's 0.9. This is not 9 point, okay? 0.9 and the next decimal place is 5. Here's the probability. This is the left tail, but what we want is the right tail. So you do 1 minus 0.8289. And something, another thing to remember, your Z scores, the tables will give you only up to the second decimal place, right? It will give you only up to the second decimal place. Therefore, when you calculate Z scores, you have to round it to the second decimal place. Then you read the table, okay? So I guess this is the answer, 0.17106. Can all of you get that value? Any questions, anything unclear? Okay, so you should understand the normal distribution very thoroughly because you are using the normal distribution. I mean, you can't hide from it. Okay? You will be using it almost all the time when you do data analysis. Okay, right. Now we move on to something a little bit different. What if you want to find in between probabilities? Okay, say for example you want to find the probability. Now I have only a part of the table, okay, a little bit different, but that's okay. Just an example to show you how this works. I want the probability in between z-score 0.22 and 0.56 positive. I need the probability in between. Okay, if I draw it, here's my bell, symmetric about 0, all positive. So here's 0.22 will be somewhere here, 0.256 somewhere here. I need in between. So this area, how do you find this one? So when you read the table, you always get the whole left tail, right? You get the whole left tail. Now what you need is a portion of this area. How do you find that? Okay, so this is how we do. We read the larger number, 0.56 first. Okay, so we read 0.56 this area first. Okay, so can you find that area 0.56? Okay, 0.56 is 0.7123. Okay, so this area is 7123. Okay, and then we read up to 0.22, the next one, somewhere here, right? We read, I'll use another color. So then we read the smaller one, 0.22, this area. What is that area? So here's 0.22. This area is 0.5871. Now what do we want? What we want is only the blue one, right? So how do you do that? You can subtract this unwanted red part. You will end up with the area you want. See, you have everything from negative infinity up to 0.56. That area 0.7123, and you have some unwanted area, this area, unwanted stuff, everything left to 0.22, you don't need them, so subtract it. How do? You get 7123 and subtract 5871 from it, right? So you'll end up with 0.1252. Okay, is this clear to all of you? This is how you find the in between areas. Okay, shall we try another one? Right, can you find this one? Probability Z is between, I'll give you some easy one, 0.6 and 0.8. Can you find this probability? Give me, how do you do the subtraction? Which value subtract which value, and the answer. Okay, yes. So you have 0.7881 minus 0.7252, which will be 0.0624. Right, so I think you can find it. So here's 0.80, yes, 0.60. Subtract those two values, you get the answer. Right? So I guess this is not hard, okay, for you. If you find the pattern, it's very simple, reading the table. Okay, yeah, thanks for the answers. Now, what if you want, I'll give you another example. What if you want these tails? Say this is negative 2.5 and this is positive 2.5. You need to the right and to the left, these tail areas. How do you find that? Right. Okay, so I have the second example. Why did we subtract? Which one? 0.95. I think you're asking the 0.6 and 0.80. Is that what you want? What is 0.95 question? The second example is in between 0.6 and 0.8. Okay, so I'll show you. I'll draw the. So here's your 0.8 somewhere here, 0.6 somewhere here. You need in between. Okay. Okay. So is it 0.1252? Okay. Anyway, so I'll explain it again how to find the in between using this one. So if you want the in between of 0.6 up to 0.8, okay. So when you read the table for 0.8, you get everything from left tail up to 0.8, everything. So when you read 0.8 from the table, that is 0.7881. Okay, so this 0.7881 will be the whole area to the left of 0.8, this 0.8. But what you want is only starting from 0.6 up to 0.8. So you have some unwanted stuff, right? So up to 0.6, this area you don't need it. So you have to get rid of it. So you read up to 0.6. So that will give you this unwanted area. So up to 0.6, it is 0.7257 here. So you read up to 0.8, which is 0.7881, and then subtract the unnecessary area. Unnecessary area is up to 0.6. Up to 0.60, you have the probability 0.7257. So you subtract it, you get the answer. Okay, so you need something else. Okay, so it is this one. 1 minus 1. Okay, right. So in this one, right. So you need, okay, someone need the explanation of the right tail. Okay, so I'll explain it again. So your Z score is 0.95 and you need the area to the right of 0.95. See this colored area. Okay, so when you read the table for 0.95, what you get is always the left tail. See, the table explains it clearly. Area to the left. Always the table gives you the area to the left. So when you read 0.95, this 0.82894 is this area to the left. This is the area, 82894. But what we want is the other side. You know the total area is 1, that is the total probability. The total probability under the curve or total area under the curve is the total probability 1. So this is the complement. Okay. So this uncolored area you read from the table, but what you want is the rest. So in order to get the rest, you do 1 minus. Why 1? Because that is the total probability and this total area under the curve is 1. So you subtract this unwanted area, so you get the area you want. Is that clear now? Okay, so I guess you got it. Right, now another problem. If I write it like this, yes, it is the same. Why? Because probability at Z equals 0.6 or 0.8, they are 0. So it doesn't matter whether you use the equal sign or not. It's not going to change anything. It's the same answer. Yes. Okay. Any other question? Right, so we know now you know how to read the left tail, the right tail, and also the in-betweens. Okay. Now I'll give you one more example. I want this area. Oh, we were talking about the tails, right? We didn't finish it. Okay, let's first finish this one. The area to the right of 2.50 and left to negative 2.50. How do you find this one? You can do this in a harder way, a longer way, or an easier way. What do you think? Now, remember, normal distributions are symmetric. Okay, so the negative and positive same z-score, these areas will be same. Okay, so the area to the right of 2.50 and area to the left of negative 2.50, these two areas, they are same, but because of the symmetry. Okay, so that means the probability of z greater than 2.50 is same as the probability z less than negative 2.50. This is by symmetry, because this is the symmetric distribution. Therefore, if you can find negative 2.50 this area and multiply it by 2, you get these two areas. Okay, so let's read negative 2.5 because it's easy from the table. Negative 2.5 is here. See, 2.50 is 0.00621, right? See, 0.00621. So this area is 0.00621. By symmetry, this area is also 0.00621. So if you want these two probabilities, you can add them together very easily by symmetry because of the symmetry of the distribution. Okay, so that is something also that is useful to you when you do calculations. Okay, so now you know how to read the table, the left tails, right tails, in betweens and everything. Okay, and let's do proper examples later, but here's something else. You can do the reverse also. What does that mean? If you know the probability of the area, you can find the z-score. That is the reverse. Okay, so here's an example. Suppose you want to find the z-score where the area to the left is let's say 0.92647. I want the z-score where area to the left is 0.92647. How do you do that? What do you have to do? So when you see this probability, it is greater than 50%, so it is in the plus z-score. Yes, I have given you a part of the table. You have to find this number or a value closer to that from these bunch of numbers inside. 0.92647. So whereas 0.99 is here, 92 is here, 923, 925, 9C. See, you have 92647. So what is the z-score? What is this z-score? Yep. 1.45. Can you all see that? See, you have 1.4 and it is under 0.05. Okay, so everybody got it, 1.45. Okay, so that is easy. What else? Let's try another one. I want area to the left. You can do this with the negative also, okay, because I have only the plus part here. I'll do that. Okay, I want this area is 0.59. What is this z-score? Now you have to find a value closer or the exact value from the table. 0.59 will be somewhere close to 0 because of 0.5. Okay, so I have 0.23. So what do we do? Okay, so when you see 0.59, you have to go for the closest one. Okay, what are the candidates? You have 0.59095 and also you have 0.58706. Okay, so 0.59 will be somewhere in between. Which one is the closest? 58706 or 59095? You have to find the gap. Okay, so 58706, there's about 204 some deviation, but here it is only 95 deviation. Okay, so therefore the closer value is 0.23. Okay, that is the closest value, 0.23. Okay, so always we go for the closer value. Look at the right and the left two candidates and pick the one which is closer. Okay, right. So that is how you read the table, both sides, probability and Z scores. Okay, now that is how you read the Z table. Now let's see how we can use it to answer an exact question. Okay, so we come back to our exam scores. Okay, so we have these exam scores, random variable X, which follows normal distribution with mean 80 and standard deviation 8. Sometimes some questions gives you the variance. Be careful. Okay, then you have to get the square root. So here's the example. So let's try to find these probabilities. What is the first one? Probability that X is greater than 85. That means you select a student randomly. That student, what is the probability that student has exam score greater than 85? So let's draw it. It's easy when you draw the bell. Exam scores symmetric about 80. This is the original normal distribution. Okay. And 85 will be right to 80. We need greater than 85 this area. Right? So what do? You have to first transform it to the standard normal distribution. Then you can read the table. Standard normal distribution, symmetric about 0. How do you standardize? You find the Z score for this limit 85. So what is the Z score? X minus mu over sigma. So that is the standardization. Your X is 85, mean is 80. It is given. Sigma is 8. You do this calculation. So what is the value? 85 minus 80 is 5 divided by 8, which is 0.62, right? So this is, when you do the standardization, the corresponding Z score for 85 is 0.62. And if you read the table and find everything to the right of 0.62, these two areas are same. It's the same area. So that is the beauty of this normal distribution. Okay. So that means probability X greater than 85 is same as probability Z greater than 0.62. Okay. So I'll give you the table, then you can use 0.625 or 0.625. So what do? You have to round it to read the table. So that will be 0.63, right? Because you have to go for only 2 decimal places. Okay. So here's the table. I think this will be enough. Here's the table. Find the probability and tell me what is the value. Remember, it is the right side. You read the table and get the left tail. So find the answer and tell me. Okay, so I can see some answers. 0.63. That will be 1 minus 0.73565. 26435. Okay, so this is 1 minus 0.73565. So the answer is 0.26435. So if you want to write it, you can write it like this also, 26.43%. So that is the answer. Is this clear to all of you? Right. So the normal distribution, and when you transform it to the standard normal distribution, and when you find the area under the curve, they are the same. Okay, the area is the same. When you read the Z table and find the probability, it is same as the normal distribution, the probability you want. Okay, right. Shall we try the next one? Probability that X is less than 60. So here's my distribution. The original one, symmetric about 80. 60 is to the left of 80. You need everything less than means to the left of 60. Standardize it. Find the corresponding Z score. Okay. And then read the table and you can find the answer. So what is the Z score? X minus mu over sigma, which is 60 minus 80 over 8, which is negative 20 over 8. Z score will be negative 2.50. Okay. Is that all? Is that clear to all of you? So I'll give you the table, negative table. Okay, find the value. So you get the answer straight away from the table, which is 0.00621. So you can see that, see, negative 2.0 is here, 00621. So I write the answer. Okay, so if you want, you can write this as PZ less than negative 2.5. Okay, and the answer is 0.00621. Okay, right. Is this clear to all of you? Right. Okay. Now try the next one, 70 to 90. Yes, 80, 70 is to the left, 90 is to the right. It's something symmetric actually. When you answer this question, you can do it in many ways because of the symmetry. Find these Z scores. First, find the Z score for 70. That's what is the Z score? Negative 1.25. Yes. Well, it is the half of the negative 20 over 8, so you can find it negative 1.25. By symmetry, what will be the other Z score then? See, 80 and 90 is the same deviation, 10 points, so this should be positive 1.25, right? That is by symmetry. Okay. So you have to read 1.25 and subtract negative 1.25. Okay, so that is one method. Or you can read negative 1.25. I'll show you an easier way. What is negative 1.25? See, negative 1.25 is 0.10565. I got the answer. Okay, let's see. 1.25 is, which means this tail is also 10565. Okay, so what is this area then? Colored area will be 1 minus 2 times 0.10565. So you subtract the unwanted tails, right? So can you find this answer? Or if you read up to 1.25 and subtract negative 1.25, again you will get the same answer. Just one more trick I wanted to show you here, right? So what is the answer? .7887. Okay, right. So I hope you can figure it out. Is this clear to all of you? Finding the probability. Right. So we move on to the last part. We need the 80th percentile of exam scores. Now the reverse. The 80th percentile of exam scores. How do you do that? What do you know now? 80th percentile. The meaning of 80th percentile is whatever at that Z score, at that point, you have 80% of data fall into the left. 80th percentile is 80%, which is 0.8. So you have the left tail 0.8. So find the Z score, which is closer to 0.8. Okay, 80th percentile. Right, so I'll give you the table. You find the value closer to 0.8, the Z score closer to the 0.8 probability. First find the Z score. So what is the Z score? You have to go for the closest one, 0.84. Thanks, Manisha. That's the closest one, right? See, 0.80, you have two candidates. That will be these two values, 0.80234 and 0.7995, right? 0.80 is in between these two. Now, if you look at the closest value, it will be 0.7995, only 45 point deviation, but this one has 234 deviation. Therefore, the closest is 0.7995. Therefore, the Z score will be 0.84. Is this correct? Is this clear to all of you? 0.84. Okay. So let's use it. 0.84 plus 0.84. Now, is this the answer? We need the exam score, not the Z score. So how do you find the exam score? Exam score is X, right? We know the Z score, which is 0.84. So find X. You know mu, you know sigma. So calculate. Sigma is 8. Therefore, 0.84 times 8. Take this negative 8 to the other side, positive 80. That will be your exam score, right? Can you find this one? 0.84 times 8 and plus 80. Yes, what is the answer? 86.72 score. Okay, exam score is 86.72. So what does that mean? The 80th percentile exam score is, let's say, 87. What does that mean? What is the meaning of this 80th percentile? That means 80% of students got exam scores less than 87. That is the 80th percentile. Okay, so this 87 means 87 is the 80th percentile. That means 80% of the students in this class got exam scores less than 87. Okay, so you need the percentile, right? So I'll explain it again. You need the 80th percentile. The meaning of the percentile is whatever that Z score to the left of the area is 80%, 80th percentile, 80% of probability or 80% of area is to the left of whatever that point, the 80th percentile. So 80% is 0.8 probability, 80% means 0.8, right? So you read the table where probability is 0.8 and you find the corresponding Z score for that, right? So this 0.8 probability, it's somewhere in this table, this bunch of values, right? So we found two candidates, 0.79955 and 0.80234. So these are the values to the left and to the right of 0.8, 80%, 0.80, right? And the closest is 0.79955. The Z score for that probability is 0.84. So you write 0.84 as the Z score. So at Z score 0.84, 80% of area is to the left of it. That is the 80th percentile. Okay. Now you found the Z score of the 80th percentile, but what we want is the exam score. That is the original variable X. So in order to find that, you again use the standardization calculation. Now it is the back calculation. You know Z, you have to find X. Z is 0.84. You know mu, you know sigma, put them in the equation to solve for X. So you got 87. This is the exam mark or the exam score. Okay. Is that clear now?
Yes, madam. Thank you, madam.
Okay. Now, if you go back and think about your Z score in your A-level exam. Now, can you understand it? Can you understand what it says? Okay, say for example, let's go to the, okay, look at this table. Now suppose, let's say a person called Saman. His Z score is, for A-level exam is 1.97. What does that mean? 1.97 will be somewhere here, right? 1.97. So you can find the probabilities to the left and the right here. 1.97. Yes, 1.9. Yes, 7. 0.97558. Let's say 0.97. Okay, just to explain it. Okay, so this is 0.97. If this is 0.97, what is this area? This is 97%, right? 97%, and this is 3%. So having an Z score 1.97 means what? So if you think about the same group of students as someone who took the exam, only 3% of students got results greater than Saman. All the other 97% of the students have results less than Saman. So Saman has a very good exam, very good Z score. Only 3% of the everybody who sat for the exam, only 3% got more results than Saman. The other 97%, their exam results are lower than Saman. Is this clear? Now, suppose you have, now you can look at your Z score and find it. Suppose someone got the Z score 2.32. 2.32. What does that mean? 2.32 is 0.9898. So let's say 0.99. So this area is 0.99 or 99%, 1%. What does that mean? So for this student who got Z score 2.32, only 1% of students have higher exam results than this student. The other 99%, all of them are less results than this person. Okay, so you can see how this Z score works, and that is how you have ranks. Okay, you have the ranks, and this is how they give the cutoff for whatever the positions available in the universities, number of available positions. They find that probability. So the probability that covers the maximum amount of all the universities for, let's say, medicine, they find that probability, and whatever the Z score for that, that is the cutoff. For everybody who have greater than the cutoff, they can go to that faculty. Okay, so that is how the Z score works. Okay, right. So it's 3 o'clock now. Shall we do a group work? Right, here's the example. I'll give you a few minutes to note it down. And then I'm going to put you into breakout rooms. You know the procedure now. We have how many students today? 32 students, maybe 5 breakup rooms. Okay. And you have to find the answers and share the answers after we combine the rooms again. Okay, so anybody who cannot attend today, or anybody who lose connection and miss the group work, I will upload this to the your LMS as a group work assignment. Anybody who miss it, they can redo. Okay, for those who have attended today and did the group work, I will count their names. But if any of you missed today's one, so please pass the message. If they couldn't attend today or lose the connection and they had to leave somewhere in between or middle, they can do this work and as an assignment and upload it. But those who are doing the work today, they don't have to do it again. Okay, is that clear? So it's very similar to the one we did. Yeah, very easy. Note this down. How about the Z score, the Z table? Can you get a screenshot or something of the Z tables also? Then you can use it. Or if you have when you are, if you are online, you can search the standard normal table in Google and you will get the tables quickly. Okay. Anyway, just note down the information you need, just the mean and the standard deviation and the questions. Okay. Okay. Do you need more time? Do you need more time? Everybody done copying the question? Okay, so I will show you the table. Can you get a screenshot or something for your reference? So here's the negative side. This one. Okay. Here's the positive side. So usually I print this and give to you in class, but with this setup, I cannot do that, but I will upload the 2 pages separately for you to refer, okay? So here's the plus side. Okay, now I'm going to make the breakup rooms, okay?